Hello, welcome to lesson 3. In this lesson you'll learn about Git. I'll start by explaining what Git is, after which you'll learn about Git Fundamentals. Next I'll show you how to secure Git access using Git access tokens, and then you'll learn how to work with branches and merges. In the last video in this lesson you'll learn how to organize Git repositories for GitOps environments. So one of the essential components in GitOps is Git. So let's talk about Git. Git is a distributed version control system. Version control because you can easily manage different versions of files. Distributed because it has a distributed nature, where developers can work in projects together, where each file revision is stored in the system. Old versions of files are always available, and a log is maintained of who made which change to which file. And Git is distributed because it allows developers to work offline after cloning a remote repository locally. The core component in Git is a repository, which can contain different development branches. Developers and users can easily upload as well as download new files to and from the Git repository. And in order to do so, a Git client is needed. Git clients are available for all operating systems. So no matter if you're a Windows, Mac or Linux user, you can use it. At the other end, there are the different platforms. GitHub is probably the most important platform. Many open source projects are hosted on GitHub. GitLab is the common alternative for GitHub. Apart from that, private Git servers can also be hosted. But in this course, we will use GitHub as a standard platform, for the simple reason that it's the most used platform of all of them. It was created by the founder of Linux himself, and that probably explains why it is doing so well. Now the easiest way to get started with Git is by using an existing Git repository. We have already done that in the previous lesson when you used git clone to create a linked copy in a newly created directory that will continue to synchronize. Will continue to synchronize, that means if you are using git pull. Git pull incorporates changes from the remote repository in the current branch. And during this process, diverging branches will be reconciled. You use this to update the current local copy. Then there is git fetch. Git fetch retrieves the latest metadata from the original branch without fetching changed files. You can use this for checking before actually pulling. If you want to analyze, you can use git diff on your current repository followed by origin so that you can see the changes. The last way of using a repository is not really something you do from the command line. It's git fork. It's what you do on your Git server to create an independent copy of the original Git repository in your GitHub account. And you can easily do that, and that's legal because it's open source. Now if you are going to work with Git, you should understand the Git workflow. After cloning, the developer makes changes to the working tree. And all changes are made to the local repository. That's the local directory on the developer workstation. Developers can push changes to the remote repository. And if the local repository is network accessible, the owner of the repository can even pull changes from it, which is not so very common. In most cases, it's the developer who pushes the changes to the remote repository. Now, while working with Git, different trees are used. A Git repository contains 3 trees in total, which are maintained by Git. And the trees are stored as files in the .git directory that is created in every Git repository. The working directory is what holds the actual files. So that is what you see if you use a Linux command like ls, for instance. The index acts as a staging area, and the head points to the last commit that was made. When working with Git, the git add command is used to add files to the index. And then you commit these files to the head using git commit -m followed by the commit message. Once you've done that, you can use git add origin remote repo name to connect to the remote repository. After adding, you complete the sequence using git push origin main, where main is the name of the actual branch that you want to push changes to. Nowadays, the most common branch name is main, but you may find other names as well. Let me make a drawing to show you how exactly all of this is related. Alright, let's try to understand the Git procedure. So it all starts on the Git server. And from the Git server, you are going to use a git clone command. And this git clone command or git pull command comes down to the same. That makes that you have your files on what we will call the Git client. Now from the Git client you are going to work with your files. So we call it the working directory, and that is where you are going to add your files. So in the working directory you apply your changes, and these changes need to be added using git add. And when you add your changes, they are internally added to what we call the Git index. Now from the Git index, they need to be written to the head. And in order to write them to the head, you have the git commit command. And once the changes are in the head, they can be pushed back to the Git repository. So from here, you want to make sure that your local changes are applied to the Git server. And that is where the git push command comes in, and that completes the circle of Git. While working with Git, your files can have different states. The git status command can be used to request the current file state. And you will find your files to be in 3 different states. Modified means that the file in the working tree is different from the file in the repository. Staged is what you find if the modified file was added to a list of changed files in the index. And committed is what you see if the modified file has been committed to the head and is ready to be pushed. And after committing a file to the local repository, it can be pushed to the remote repository. In the next video, I'll show you how to do all of this. Okay, so what do we need to get started with Git? Well, we need to set Git client options. There are global options. Global options are written to the user's home directory in a .git config file. You can also use repository-specific options, which are stored in the .git directory. If you want to see the options currently used, use git config -l -global, and that will show you all the global options. And you can set global options like your user information. Use git config --global user.name followed by your git username, and user.email followed by the email address that's associated to your git username. If you want to set up passwords, you'll need to use the Git client and set up a credentials cache. In the next video I'll show you how to do that, as well as how to use advanced Git credentials. To set options on a project-only basis, just use git config without --global. So how do we work with Git? Well, working with Git starts on the Git server, where the upstream repository is created. And next, a directory on the local workstation is created. And in this directory you are going to use git init. Git init is what you use to create the metadata in the workstation directory. And next, a readme.md file is added, containing information about the contents of the Git directory. This readme.md in real Git repositories is pretty important, because you are going to provide your documentation in it. And based on that documentation, your users know exactly what your project is doing. Now from there, the normal Git command flow can be applied. So that will be git add to add all the files to the staging area, and git commit -m commit message to commit these files to the head. To push files from the head to the remote repository, you use git push. And different push methods are available. You can use git config --global push.default to set the default push method. You would use push default matching to push all branches, and use push default simple to push the current branch only. Push default simple is the recommended and default value, and you probably just want to keep it like that. Now let me demonstrate how to work with Git. Here on the slide you can find the steps in the demo. So if you want to, just pause the video at this point and work your way through these steps, and then compare with what I've done. Alright, so here we are in my GitHub account. I'm already logged in because I'm using this a lot. Here we can see the current signed in information, and the settings is here. And what we see here is all the Git repositories that I'm using. So I want to create a new Git repository. And in order to create the new Git repository, it's not really rocket science. I'm clicking new. So here it's asking for the repository name, Git demo. It's telling me Git demo is available, so Sander van Vugt /Git demo is what we are going to use. You don't need anything else of what is listed here. Just click create repository to create the repository. So next, it's even telling you what to do. If you want to make it easy on yourself, just copy paste this. I don't want to copy paste this. I want to provide some insight. So at this point, we're ready to move to the Linux machine and take care of the client part. Okay, so now I'm on Linux, and I can set my generic parameters. So git config -- global user.email followed by my email address. And likewise user.name followed by my username. So what you see here, I'm on a Linux system, but this is not specific for Linux because we are working in the Git client. And in the Git client, well, no matter your operating system, it will always be the same. There's one more option that I would like to set, and that is git config -- global init.default branch main. Now the thing is that in the past in IT, throughout different projects, you would often find the name master. Master is now deprecated terminology, but if you don't change it, Git is still creating a master branch. If you don't want that to happen, then you can use this init.default branch main, and that will make sure that your main branch will be made main. Okay, now I'm going to create my Git directory. So mkdir git demo. And I need to go in the Git directory using cd. Then git init is creating the Git metadata. So the head and the staging area, that is all in this metadata directory. You can see that if you do tree on Git. Oh, we need to install that. Sudo apt install tree. So now that we have installed tree, we can try it again. Tree.git. And there we can see the exact configuration that is created in this metadata environment. No worries, you won't ever work with this, but it's just cool to know that what is happening behind the scenes. So let me create a file using my favorite editor. Don't be scared for Vim. You want to use Nano, that's okay. It's just we need a text file. This is a demo git project. Please ignore. I'm doing this because my Git account, well, I have people following me on Git and they're checking out what I'm doing. So for the people using my Git repositories, this is just a matter of politeness. Next I'm using git add star. And what is git add star doing? Well, if we use git status, now we can see that no commits yet, and we are on the branch main and changes to be committed. New file readme.md. I can also unstage it using git rm -- cached on this file. If I want to get it out of the staging area, which might be necessary if I need to apply more changes, for instance. Next, git commit -m initial commit. And another git status, and that is showing that we are on the branch main and nothing to commit, working tree clean. So all files are now ready to be pushed. So how is that happening? Let me show you the second slide so that we can continue. Okay, so I'm using git branch -m main. Why is that? That's not really necessary, just to indicate that we're in the main branch. And next, git remote add origin. https://github.com/my name. In my case, it happens to be Sander van Vugt. And something, well, that's the name of the Git repo, in this case, Git demo. And now I have added the remote Git repo to my local metadata, and I can use git push -u origin main. And then, oh boy, what is happening? It's prompting for a username. Now that is confusing. My username is my very secret username, and my password, what password is that? Well, I can tell you, if at this case you use the password that you are using to log in to GitHub, you get the option support for password authentication was removed. And that is because nowadays we should use personal access tokens. And in the next video, I'll explain how to use personal access tokens. So we'll be back, but let's first talk about advanced authentication. So we have just seen that normal user password-based authentication doesn't work anymore. You need to use authentication tokens. Passwords are very insecure, therefore no longer supported, and personal access tokens are the alternative. So you must create a token. While creating a token, you can even generate a token with specific permissions. My advice would be set all permissions to avoid confusion. There's classic personal access tokens. They can be used to never expire. There is also a newer type of token, the fine-grained access token, which can be configured with access to specific parts of Git. Notice that this functionality is now also being integrated in the classic personal access token. You'll see these fine-grained access tokens still in a state of beta. I don't know how that's going to end at this moment. So in order to generate a token, you go to the Git website. You select your account, then the settings, and on the left the developer settings, and then you can generate a token. And on the Linux CLI, you enter the token when you are prompted for a password. Let me show you. Here I'm back on GitHub, and I am going to check my settings. And all the way to the left, there's the developer settings. And there we can see the personal access tokens. So I want the tokens classic, and I'm selecting generate new token. I want the classic token for general use, that's okay. And I'm calling it Git demo. Now I know on beforehand that I'm only going to use this token for a few days. So expiration 30 days, that is fine with me. And for the rest of it, there's the permissions. I would say do yourself a favor and just select everything. That's not needed, but we shouldn't be talking about advanced permission setup in this class. We just want to make sure that we are not blocked in anything that we want to be doing. And next you use generate token, and that will generate a token for you. So let me copy the token. And then we can get back to the Linux system where it is used. So on the Linux system, I like storing this token in a file so that we can easily access it later. We need to store it securely. So vim git token. Oh, stop. Is this smart? Look at what I'm doing. Of course this is not smart. I'm in the Git repository. Do I really want to store my very secure Git access token in the Git repository? That's not very smart. So let me make that git vim /git token to store it at a different level, outside of the Git repository, because it shouldn't be stored. And haha, you can read my token. Well, good luck with it. It has a validity of 30 days. I don't care if you can read it. Now I can get back to my Git demo environment, and I can use a command like git push. And this git push is asking me for a username. And it's asking me for the password, and this password, that will be my authentication token. Now the annoying thing is that I will need to do this every single time when I do a git push. The git token is nice, but in addition to the git token, we also want to use a credentials cache. Let's talk about the credentials cache. Okay, so tokens are now the standard way to authenticate, and because of that, global username and password settings no longer work. And as tokens are the standard, you should create a credentials cache. Well, you don't have to, but then at every single push, you have to enter your username as well as the Git token. That is annoying. And for that reason, you need to install the GH client to create the cache, and then you use the personal access token to establish your identity. Let me demonstrate how to do this. For your convenience, the different steps that I'm going to demonstrate are here on the slide. So I would advise start by using your favorite search engine and look for a GitHub CLI install, for instance. And what do we see? We see two options, installation instructions and GitHub official command line tool. Does it matter where we go? I like taking it from GitHub. This is the Git repository for the Git CLI, and if you go to the README, at the same time that allows you to see what READMEs are normally doing. This is really a nice README with useful information in there. This is really a nice README with very useful information in there. Here we can see Linux and BSD. It has a Debian and RPM repository. That's what I want. So here we can see the commands to install the Git client using apt, which works on Debian, Ubuntu and a couple more. Just copy all of these commands, get to your CLI and paste it. So apparently it was already installed. Well, that's even better, and that doesn't really matter. What matters is that at this point we can use gh auth login, which is asking me, what do you want to do? Well, I want to set up authentication for github.com using HTTPS as a protocol, and I want to authenticate with my GitHub credentials. Yes, please. How do I want to do that? Well, I want to do that using an authentication token. That is what is bringing everything together. Now, the only thing that I need is my authentication token. So here we go. It's still here. I need to copy it again. And then I'm pasting it, and oh, I'm getting bad credentials. Probably a copy-paste error. Let me try that again. And there we go. gh-config set, logged in as Sander van Vugt. So at this point, we have a credentials cache, and that is going to be so useful for everything else we are going to do with GitHub on this machine. While working with Git, it's very important that you know how to deal with branches and how to merge them. So what is going on? Well, branches are used to develop new features in isolation from the main branch. And the main branch is the default branch. Other branches can be manually added. Any Git repository can have multiple branches to allow developers to work independently. Everybody can have their own branch, and by using these branches you can have teams of developers working on the same functionality before committing that. Now, once the work in the branch is complete and everything has been accepted, you can merge the branches back to the main branch to ensure that everything is the same. Now, while working with branches, you are going to like the git diff command. The git diff command shows you differences between the branches, and it will also tell you if there are any potential conflicts. What should you think of a potential conflict? Well, a potential conflict is where a file in the main branch has taken a different development as the same file in your new branch. Then you need to manually fix that. And if such conflicts don't exist, then you can merge the other branch back into the active branch using git merge. All right, so how do we use these branches? Well, you use git branch dev branch to create a new branch and start using it. In this case, the name of the new branch is dev branch. There's also the old and deprecated way, git checkout -b dev branch, which will do exactly the same. But git branch is a more modern way, you should use that. Then use git push -- set upstream origin dev branch to push the new branch to the remote repository. Once you're done, you can use git switch main to switch back to the main branch. And git checkout main would do the same in the old and deprecated way. And if you are completely done with your branch, you can use git branch -d dev branch to delete it. Now, while working with branches, the merge is important to understand. After you make changes to a branch, the changes can be merged into the main branch. So before you merge, you should have a look at the differences. You can do that by using git diff on both the branches, so in this case main and dev branch. And after using git checkout main, you can use git merge dev branch to apply the changes from the branch to the main branch. If files have been modified in multiple branches, automatic merges are not possible because merge conflicts exist in that case. And if that is the case, you need to resolve the merge conflict manually by editing the affected files. The message, if that is the case, will be very clear. Shouldn't be any confusion about it. Let me demonstrate how to use these branches. Okay, let me use git branch new files and git status. And that's telling me that we are on the branch main. So I just created the branch, I'm not using it. If I want to use it, I can use git switch new files. Alternatively, I can also use git branch -b new files to immediately get into it. Git status at this point is verifying that we are on the branch new files. And if you want, git branch -- list is listing all the branches that are available. This is a nice, convenient, different way to check the branches that you have. Now I'm creating a file with some contents. If you are testing Git, avoid using empty files because Git is looking at the contents of the file and an empty file might just be considered a rename. That's not what you want to happen. So next I'm using git add star and git commit -m3, and all of this is happening in the branch, right? And git push -- set upstream origin new files. And now let's use git diff new files main. Here we can see the differences. It is written in the typical Linux diff notation, not very readable, but you can see at one end we have 3.txt and at the other end we have not. So this is how you should read it. So we first see the current branch. This is the current branch, and then we have the other branch. -3 means that -3, the 3 is not available in the main branch. And that is what we need to fix. Now, how are we going to fix it? First, we are using git switch main and git status to verify. We're in the main branch. ls to check we don't have the 3.txt file, but if I want it in here, I can use git merge new files. And that has merged the content of new files into the main branch, and now we are completely up to date. Now this is a simple example of how to use branches. I think this should be enough for what we want to do in this course. Alright, now we have reviewed some of the Git basics. Let's bring Git back into the GitOps environment. So how do we organize Git repositories for GitOps environments? Well, in a GitOps environment, stages are defined for different environments. And these stages and environments should be presented in the Git repositories. And common solutions are the single branch strategy and the multi-branch strategy. Now, what is that about? Well, in the single branch strategy, there is one Git repository with a specific directory for each of the environments. And the Kubernetes Customize utility is going to be used to adopt the configuration for a specific environment from these directories. Environment-specific settings will be in each of the subdirectories as different resources are required in production and in pre-production. And the advantage of this strategy is that all code is still in one branch, but customization is required to create the specific environments. You are fully going to understand this once we have brought in customization, but the thing to understand here, single branch, every environment has its own directory. The alternative is multi-branch. In multi-branch, each branch has a specific configuration that is required in an environment. As a disadvantage, there is no common code that is shared through all the environments, and that is likely to make multi-branch less efficient. That's why you probably want to go for single branch. That's also what I'm going to show you once we bring in customization in Kubernetes. Now, how do we manage configuration? Well, creating configurations for the different environments is taken care of by Kubernetes. And the core Kubernetes resources to do so are the config map and the secret. Kubernetes provides different solutions to manage configurations, and we will explore these solutions in more depth in lesson 10. We're talking about Helm and Customize. That's all. At this point you know enough about Git, also in the GitOps context. In the next lesson we are going to explore the next main component, and that is the container image.